Dear students, we shall continue the chapter Maxima and Minima. In the previous class, we solved some problems on Maxima and Minima. We studied about first derivative test and second derivative test also. Today, we will solve two more problems on Maxima and Minima by using second derivative test. You already know about the second derivative test. First, you have to find the derivative of the function dy by dx and equate it with 0 and find the value of critical points and the critical points x. Then you find derivative of the function, second derivative of the function. Then at x, second derivative at find the at critical points. If it is less than 0, maxima is exists. If it is less than greater than 0, minima is exists. Then we find the value of maximum and value of minimum at at critical points. F of x, if it is C is the critical point, you find the C1, C2, C3. It are the C1, C2, C3 are the critical values of the function. We'll solve one problem. Find local maxima and local minimum. I solved already two problems. Third one is h of x, which is equal to sin x plus cos x, where x is greater than 0 and less than 5 by 2. It's the open interval from 0 to 5 by 2 here. 0 and 5 by 2 are not included here. We find the maxima and minima between 0 and 5 by 2. First, we find the derivative of the function h dash x or derivative of sin x is cos x and cos x is minus sin x. Then we equate x or derivative of function with 0. That implies cos x minus sin x, which is equal to 0. Cos x is equal to sin x. Then 1 is equal to sin x by cos x. Then 1 is equal to tan x. 1 is equal to tan x. If tan pi by 4 is equal to 1, tan pi by 4 is equal to 1. We know that. Therefore, x equal to pi by 4. It's the critical point. It's the critical point. Is equal to x equal to pi by 4. Then we find second derivative of the function h double dash x, which is equal to derivative of the derivative function. Cos x derivative is minus sin x and derivative of sin x is cos x minus cos x. If we find at double dash x is pi by 4 at pi by 4 minus sin pi by 4 minus cos pi by 4 which is equal to sin pi by 4 is 1 by root 2 and cos pi by 4 is equal to 1 by root 2, then which is equal to denomination is root 2, it's 1 minus of minus 1 which is minus 2 by root 2 which is equal to root 2, it's root minus root 2. It's root 2 into root 2 divided by root 2. Root 2 gets cancelled. Its sign is minus. Therefore, h double dash pi by 4 which is equal to minus root 2 less than 0. It's less than 0. Thus, we find the first derivative of the function and equate this one with 0. Then we find the critical point x equal to pi by 4. Then find the second derivative of the function. It's equal to with minus sin x minus cos x. Then substitute the value of x. It's a critical point which is pi by 4. Second derivative of the function at pi by 4. The value is becomes it's minus 1 by root 2, it's also 1 by root 2, minus, it's minus 2 by root 2 is equal to minus root 2, minus root 2 is less than 0. It means local maximum value, local maximum exists at x equal to pi by 4. Then find the value of maximum. Maximum at pi by 4 is, we find it substitute the value of x in this function. H of x is equal to sin x plus cos x. Therefore, h of pi by 4, h of pi by 4 which is equal to sin pi by 4 plus cos pi by 4 which is equal to 1 by root 2 plus 1 by root 2 which is equal to 2 by root 2 which is equal to root 2. Therefore, h pi by 4 which is equal to root 2. Therefore, maximum value, maximum local maximum, local maximum value at x equal to pi by 4 is root 2, is root 2. Therefore, point of local maxima is pi by 4. Local point of local maxima, point which at which point the maxima exists. That point is x equal to pi by 4 and maximum value is root 2. Maximum value is root 2. First, you note down the steps involved in finding the local maxima by second derivative test. Next, I will solve one more problem. One more problem like function which is a trigonometric function. I will take here polynomial function. F of x equal to 3x4 plus 4x cube minus 12x square plus 12 plus 12. Find the local maxima and local minima f of x equal to 3x to the power 4 plus 4x cube minus 12x square plus 12. Then here we find the f dash x. First we write the function which is 3x to the power 4 plus 4x cube minus 12x square plus 12 is the function. Then we find the derivative of the function which is equal to 4 into 3, 12x to the power 3 plus 4 into 3, 12x to the power square 2 or 12x square minus 24x. Then derivative of 12 is 0. Here 12 is common. Here x to the power 3. Here x also common. 12x, x to the power 3, 2 plus 12x minus 20. Taking common x also, therefore here 12 also, here x minus 2, 12x plus x square, then x minus 2. It's f dash x. Then we equate the f dash x with 0. F dash x equal to 0. That implies 12x x square plus x minus 2 which is equal to 0. Here 12x x square plus 2x minus 2 which is equal to 0. 2 minus of x is 1x. 2 into minus x minus 1 is minus 2. Therefore 12x x taking common x plus 2 minus 1 x plus 2 which is equal to 0. Then 12x into x plus 2 x minus 1 which is equal to 0. We write 12x equal to 0 or yeah, 12x equal to 0 or x plus 2 is equal to 0 or x equal to x minus 1 is equal to 0. Here, three critical points are there. Here 12 is taken that side, is 0, therefore x equal to 0 or x equal to minus 2 and x equal to 1. Therefore, critical points are x equal to 0, x equal to minus 2, x equal to 1. There are the three critical points. You have to find the second derivative at these 3 points. First we find the second derivative f double dash x which is equal to, we know about the f dash x is equal to 12x x square plus x minus 2. If you find the second derivative, f dash x is equal to 12x cube plus 12x square minus 24x you can find the derivative easily. Here, 12 into 3, 36 x square plus 12x minus 24. First, we find the second derivative of the function. Then f dash x at x equal to 0. 0 is, it becomes 0, it becomes 0, it is equal to 24. Because 36 into 0 is 0, 12 into 0 is 0, minus 24 is the second way. Then at minus 2, if we put the value here, minus 2, 36 into minus 2 whole square plus 12 into minus 2 minus 24. We get it. 4 into 36. It is plus 4. Plus 4 into 144 plus minus 24 minus 24. Therefore 144 minus I think here is this. And that's is equal to 72, I think. Here 144 minus 48. 144 is 4 into 3. I think it's around here. It's equal to how much? 48. It's 6. Then 13 minus 4 is 96. I think it's equal to 96. 48. 96, which is 96 is greater than 0. It's less than 0. Therefore, here maximum value exists. Here minimum value exists. Here minimum value exists. Then last one is f double dash 1, which is equal to 1. It's 12 into 1 cube, 36 into 1 plus 12 into 1 minus 24, which is equal to 36. 12 minus 24, which is equal to 48 minus 24, which is equal to 4. 24 is the answer. It's also greater than 0. It's also greater than 0. Therefore, here 2 are maximum value. Here it's a minimum value. X. Here, first we find the critical points 0, minus 2 and plus 1. Then we find the second derivative of the function, which is 12, first derivative is 12x cube plus 12x square minus 24x. We find the second derivative 12 into 3, 36x square plus 12 into 2, which is equal to 24. Here it is equal to 24x minus 24. Here it is x into 0 is minus 24. But here the value is wrong, but it is also minimum value. But it is 24. 36 into minus 4 is 144, I think. Then minus 48 minus 24, which is equal to 144 minus 72. It's equal to 72. It's equal to 72, which is greater than 0. I mean, minimum value is exists because it is go wrong with it's 24. Then it's also here 24. It's also 24. 24 gets cancelled. Then 36 is the answer, which is greater than 0. Here also minimum value exists. Minimum value exists. Here at x equal to 0, maximum value exists, and x equal to minus 2 and plus 1, minimum value exists. We find the maximum value and minimum value of the function. F of 0, which is equal to f of 0 is equal to 3 into 0 square is 0, 0, 0. It's equal to 12. F of minus 2, which is equal to minus 2. 3 into minus 2 whole raised to 4 plus 4 into minus 2 whole cube plus 12 into minus 2 whole square plus 12. Here 48. It's a negative, positive, because 2 to the minus 2 to the power 4, it's 48. Then it's a negative because minus 2 to the power 3 times. It's a negative 8 into 4, 32. Then it's positive 2 into minus 2 square is 4 plus 12. We get 48 minus 32 plus 32. We get here the answer is 48 minus 32. It's a minus 12. It's a minus 12. Therefore, it's a minus. Then it becomes 0. Then minus 32 is equal to 20. It's a minus 20. Is the minimum, is the minus, it is the maximum value. At x equal to 0. It's a minimum value at x equal to minus 2. Then x equal to 1. Then x equal to 1. F of 1 is equal to 3 into 1 to the power 4 plus 4 into 1 to the power 3 minus 12 into 1 to the power square plus 12, which is equal to 3 plus 4 minus 12 plus 12. 12 will cancel. 7. 7 is the minimum value x equal to 1. In this way, we find all the critical points, then find where it is maximum and minimum. At which point maximum value exists and in which point minimum value exists. Then find the maximum value and minimum value by substituting critical points in the function. We get maxima and minima. Here all of these, maximum is 12 and minimum values are minus 20 and plus 7. Here maxima are 2, minimum value is 2 and maximum value is at 1. We find the next absolute maxima and minima in the closed interval. It's we taken here is open interval. Then we find the maxima and minima at closed interval. If it is x equal to a and x equal to b, here we find the maxima and minima of the function f of x at closed interval a and b. We find the maxima and minima with in the x equal to a and x equal to b also, because a and b are included here. We find the critical points every maxima and minima at every critical points. We add these 2 points all with this. We add these 2 points also. Then here also minima, here also minima, here also minima. In these 3 minimum points, which one is the absolute minima? We have to find this also. And maximum, here also maximum, here also maximum. In these 2, which one is the maximum? We have to find this also without drawing the graph. Find this absolute maxima or absolute minima by using second derivative test without drawing the graph. Maxima and minimum values of a function, and minimum values of the function in a closed interval. Theorem 5. If f is a continuous function, let f be a continuous function. On an interval AB, and an interval I is equal to AB, then f has the absolute maximum value, f and f attains it at least once. At it at least once means it's a continuous function in interval AB, closed interval. Then f has absolute maximum value. F attains its maximum at once, at least once in I. Also, f has absolute minimum value at least once in I. Therefore, let f is a continuous function on an interval AB, closed interval, then f has an absolute maximum value and f attains it at least once, and the same way if f has absolute minimum, it having at least once in I. Theorem 5 is this that, and theorem 6 also there. In 6, let f be a differentiable function on interval, differentiable function on an interval I, and let C be any interior point of f, then first one, f dash c is equal to 0 if f attains its absolute maximum value at C. Second one, f dash C is equal to 0 if f attains its absolute minimum value at C. Here, if f is a differentiable function in the interval I, and let C be any interior point in f, then f dash C is equal to 0 if f attains its absolute maximum value, and f dash C is equal to 0 f attains its minimum value at C. We find the absolute maximum and absolute minimum value in the differentiable function. We use the following steps, which are the steps involved here. Is step 1, we differentiate the function. First one, we differentiate the function and equate the derivative of the function with 0 and find the critical points. It may be 1 or 2 or 3. Then with including this, we take the interval points also. If it's A, B in the interval, we take A, B also including here. If these also 2 are critical points. If x equal to 3, it's a critical point including these 2. then x equal to 3, a, b. If it is a 2 and 5, then 2 and 5 also included here. 3 are the critical points. Then we find the second derivative test, and at which these 3 points we find the value of the second derivative. Then which one? In which maximum exists and minimum exists. Find all the maximum value and minimum value in of all these points. Which one is the maximum of maximum and minimum of minimum? We have to find to this one. It is the absolute maximum value and absolute minimum value. First, we find one problem. Solve the problem. Find the absolute maximum value and absolute minimum value of the following functions. In the given intervals. Here, first one is f of x equal to x cube. Here x is belongs to -2 to +2. We take here only simple problem. F of x equal to x cube. X is belongs to -2 and +2. Here, first we find derivative of the function is 3x square. 3x square. Then f dash x equal to 0. It implies 3x square, which is equal to 0. X square is equal to 0. X is equal to 0. Only. Yeah? Then the critical points are x equal to 0 and -2 and +2. 3 critical points. We have to find the maximum and minimum values of all these. We find the f of 0, which is equal to f of 0 is equal to 3 into 0, which is equal to 0. F of -2, which is equal to 3 into -2 whole square, which is equal to 4 into 3, 12. Then f of +2, which is equal to 3 into +2 whole square, 4 into 3 is equal to 12. X cube zeros cube -2 cube is equal to +2 cube. I put the value in f dash x, but f of x equal to x cube. We put the value in function. F of 0 is equal to 0 cube is equal to 0. It's equal to -8, which is equal to +8. Then absolute maximum value which is equal to 8 at x equal to 4, x equal to 8, 8 x equal to 2, and absolute minimum value is equal to minus 8 at x equal to minus 2. These are the absolute maxima and absolute minima. Here 0 and minus 8 are the minimum or maximum value, but here we find the least one is the minimum value and highest one is the maximum value. Then we write the absolute maximum value is 8 at x equal to 2 and absolute minimum value is minus 8 at x equal to minus 2. Here the following steps are followed here. Above, find the derivative of the function first, then equate the derivative of the function with 0 and find the critical points. Then we add these critical points, the interval points which are minus 2 and plus 2. These are therefore the critical points are 0, minus 2 and plus 2. Then find the maximum value and minimum value of f of x at 0, minus 2 and plus 2. Of all these value, which one is the maximum and which one is the minimum, we find and write absolute maximum value and write the minimum absolute minimum value. Let's solve one more problem and then we'll stop. F of x equal to 4x minus 1 by 2 whole square, 1 by 2 x square, where x belongs to minus 2, 9 by 2. Here, first we find the f dash x which is equal to 4 minus 2 into 1 by 2 into 2x which is equal to 4 minus 2 gets cancelled, 4 minus x, 4 minus x, f dash x equal to 4 minus x, we equate f dash x is equal to 0, that implies 4 minus x equal to 0, then x equal to 4, x equal to 4. Now, we evaluate the values of f, the values of f at x equal to 4 and x equal to minus 2 and x equal to 9 by 2. These 3 points we have to find the f of x. Then f of 4 which is equal to 4 into 4 minus 1 by 2 into 4 square which is equal to minus 1 by 2 into 16. 16 minus 8 which is equal to 8. F of minus 2 which is equal to 4 into minus 2 minus 1 by 2 into minus 2 whole square which is equal to minus 8. It's minus 1 by 2 into plus 4 which is equal to minus 8 into minus 2. It's equal to minus 10. Then last one is f of 9 by 2. 9 by 2. Now 4 into 9 by 2 minus 1 by 2 into 9 by 2 whole square, which is equal to 18 minus 1 by 2 into which is equal to 18 minus 81 divided by which is equal to here, it's equal to 144 minus 81 divided by 8, which is equal to 63 divided by 8. It's 7 point something is here. But here is one is minus 10, one is 8. Therefore, absolute maximum value, absolute maximum value is 8 minus 10, 7 point something. Which one is the maximum value? It's 8. 8 at x equal to 4. X equal to 4. 8 at x equal to 4. Value 8 at x equal to 4. Absolute minimum which is equal to minus 10. It's equal to minus 10 at x equal to minus 2. At x equal to minus 2. Here we find the derivative of the function and find the critical points including interval points also. Then find the value of x at 4, minus 2 and 9 by 2 are the critical points. Then we select the maximum value between upon these points. Maximum, absolute maximum value and absolute minimum value.